Hello all, I'm Ruthvik, and in this session, I'm going to discuss the problems from Codeforces Round 1076, Div 3. Okay, let's start. Coming to the first question, DBMB had a birthday present. He was gifted an array of n elements and a number x. But there is one problem. He only likes arrays where sum of elements is equal to x. To make the array strictly appealing to him, we can perform the following operation any number of times. Choose an index I and add x to number a of I. Add x to the element at that index. For example, if the array is 1, 2, 3, 4, 5 and x equal to 2, I can choose the index 3 and make it 1, 2, 5, 5. Like basically 3 is converted to 5. 3 plus 2 that's equal to 5. So our task is to determine whether the array can appeal to DBMB after any number of operations. And that is the question. So coming to the explanation, we are given an array of n elements and we need to make the sum of all elements of array equal to s. So basically, in one operation, we can choose an index I and do a of I plus equal to x. Or in other words, a of I equal to a of I plus x. So let's see what this operation does to the total sum of the array. So irrespective of what index I choose, if I apply the operation one time, total sum of the array will be incremented by x. Okay, so uh, as S is our final target and sum is our initial sum, right? So initially, let's check the difference between the final target and our initial sum. If this difference is less than 0, which means that our initial sum is greater than our final target, then it is not possible to reduce the sum, right? As we can only increase the sum in one operation. So if difference is less than 0, then our answer is no. Now, handling the case where difference is greater than or equal to 0, if difference is a multiple of x, then only our answer will be yes. Otherwise, our answer will be no. Because in one operation, we can do sum plus equal to x, right? So basically, we can increase the sum in multiples of x only. So our difference should be a multiple of x. And that's all. Coming to the code of this question. So initially, what I'm doing is I'm calculating the sum of all elements in the array. Then I'm taking the difference. If the difference is greater than or equal to 0 and the difference is a multiple of x, then only my answer will be yes. Otherwise, my answer is no. Now, coming to the second question, we are given a permutation of length n. Oh, sorry. Permutation of length n is an array consisting of n distinct integers from 1 to n in arbitrary order. Okay, this is the definition of a basic permutation. You are given a permutation p of length n, and we can perform the following operation exactly once. We can choose two integers L, R and reverse the segment LR in the permutation P. Our task is to output the lexicographically maximum permutation that can be obtained by performing this operation. Here we can note that we can perform the operation only one time. And permutation A is lexicographically greater than permutation B if first position I where they differ, uh, it holds that AI is greater than BI. And here we have to note that we can perform the operation exactly once. And in case if we don't want to perform an operation, like for example, in this test case, 4321 is already lexicographically maximum. So in this case, I don't want to perform any of the operation. So simply I can choose L equal to R. Basically, I can choose let L equal to R be any index, and reversing them won't change the permutation at all. So we can interpret this as we can perform the operation at most once. In the first example, what I did is that they have chosen L equal to 1 and R equal to 4, and that basically reverses the entire permutation. So it becomes 4, 1, 2, 3. In the second example, they chose L equal to 1 and R equal to 2. So 1, 2 becomes 2, 1, and we are given this permutation. Now coming to the explanation, mm, we want the lexicographically maximum permutation, right? So what I can greedily do is I'll uh, let me take a basic example 1, 2, 3, 5, 4. In the first element, it is best if I have the maximum element, right? Then I'll get the lexicographically maximum. So if I have a permutation of length 5, then it will be lexo. I can get the lexicographically maximum one if I have 5 at the first element. So let it be this case. In order to bring 5 to first element in at most one operation, the only option I have is choose this L and R. So what will happen is this will get reversed. And as 5 is initially at the end, after getting reversed, what will happen is 5 will come at the first, 5, 3, 2, 1. And the last element is 4, right? So in a permutation where first element is not equal to maximum element, what I'll do is where first is not equal to max, what I'll do is I'll simply choose L equal to first index, that is 1, and R equal to uh, location of max element in the permutation. So that if I choose this R will come to the first. Now let's see the case in which first equal to max. If first element equal to max element, what will happen is 5. Let this be the permutation 5, 3, 2, 1, 4. If first element equal to max element, I can simply move forward. Like as this is already maximum, I'll move forward. What will I get is if I remove the first element, I will get a permutation of length 4. Okay. And again, after getting the permutation of length 4, I can apply again the same operation. Check if first equal to max, then move forward. Basically, first equal to max, I'll remove this. Removing in the sense I'll fix this first element and then I'll move forward. After that, I'll be getting another permutation. Move forward and repeat. Else, if first is not equal to max, I'll take L equal to var and R equal to location of max. Location of max is basically the index where max is present, and I'll reverse this. Yeah, that's all. Now coming to the code. So initially, I'm taking the array input, and after that, I have made a location array. Location array basically contains the locations of all the elements in the initial array. Like for example, location of a of I equal to I. Basically, it will return the index where the current element is present. So what I'm doing here is for I equal to 0 to n, if a of I is not equal to n minus 1. Here n minus I. Here n minus I is the max element. Uh, like for example, if I am at index 0, my array permutation size will be n, right? So the max element will be n minus I, that's equal to n minus 0. If I am at index 1, my permutation size will be 4. So my max element will be n minus 1, that's equal to 4. So here, if a of I is not equal to max element, what I am doing is I am taking L equal to current index, that is the first index, and R equal to location of max element. And what I am doing is I am basically reversing this LR segment. While L less than R, I am swapping A of L comma A of R. This basically reverses the range from L to R. And then I'll break the for loop if I encounter a position such that it is not max. Else, what will happen is if it is a max element, then it will continue the for loop. The for loop gets continued until I encounter an index such that A of I is not equal to max element. And finally, I will print the array after applying this operation. And that's all. Now, coming to the third question. Today, KQ has an exam at Grail Academy. Okay. He was given two arrays A and B of length n. KQ is allowed to perform the following operation on the array. We choose an index I and replace A of I with A of I plus 1, or he can choose an index I and replace A of I with B of I. Now he has queries. Each query is described by two numbers. His task is to find the maximum value of sum of all the numbers, all the elements of the array that lie between L and R in every query. Here we want the maximum value of the sum. Okay. And he can also perform the operations any number of times. Coming to the constraints, here n and q lie between 1e5 and array elements are bounded by 1e4. In output, we have to output for every query the maximum value of sum of all the elements between AL to AR. So I'm taking an example. What we can do is we can either do AI equal to AI plus 1, or we can do AI equal to BI. So our first step should be that let's observe the last element. Okay. Last element, we have no other option other than doing AI equal to BI. So basically, the maximum possible value of last element can be mm, A of 4 equal to max of its current value, comma B of 4. Now coming to any other element other than last, let it be A of I. A of I can be max of, it can be its current value, or it can be B of I, or it can be A of I plus 1. Here, this is the maximum possible value of A of I. As we are coming from right to left, what we are doing is every time when we encounter an index I, we have already set the a of I plus 1 to its max possible value. So the max possible value of a of I can be the maximum of these three. Because the last initially, let's take this example. Initially, A4 will be set into its max possible value. Then after all its previous indices, next A3 will be set into A3 equal to max of A3 comma B3 comma A4. In this way, if initially A4 is set to its max value, after that A3 will be to its max value, then A2 will be set, then A1 will be set. In this way, if we come from backwards, we can keep on setting all the elements of AI to its max possible value. After that, our queries is like we have to find sum from L to R, L to R in array A. As all the elements are already maximum, we can simply find the sum. And this is pretty standard. Sum in a range L to R can be calculated in O of 1 using prefix sums. So basically, our goal is to first we will create a prefix sum array of A, uh, which and after that, for a sum in range L to R, our answer will be prefix sum till R minus prefix sum till L minus 1. And that's all. Coming to the, I'll show in the code. Yeah, here, here I'm taking A and B input of A and B arrays. And after that, I have pushed back 0 in array A. The main reason for that is for simpler implementation because in the last element, if I apply this operation at the last element, then I'll get out of bounds here, right? So I simply inserted a dummy value at the end. Dummy val equal to 0 at end of A. So that if I am at last element I equal to n, then basically this value will be 0 and this max won't be affected. Max will be simply max of ai comma bi. So yeah, so for every index I have taken the max. I have set it to its max possible value, max of ai comma ai plus 1 comma bi. And after that, here I am calculating the prefix sum array of a. And after calculating the prefix sum array, uh, we have Q queries, right? I'm taking the query input like we are given L and R. And for each L and R, the answer will be prefix sum till R minus prefix sum till L minus 1. Prefix PRER minus PREL minus 1. And that's all. Coming to the fourth question. In the game, we are given n swords, each with its own strength. In particular, sword number I has a strength A of I. Now, the game consists of n levels, each of which features a monster. We are starting at level 1, and to pass level I and move to level I plus 1, you need to defeat the monster at level I. And to defeat the monster at level I, we need to deal it BI sword strikes. Basically, the swords are very fragile, so we can only deal one strike with a sword before it breaks. You can complete the level N or run out of swords. You can finish the game and proceed the score calculation. Like basically this line says that we complete the game if we complete the level N or we run out of the swords. Okay. So before the game, we are allowed to choose a difficulty level. If I choose a difficulty X, swords with a strength less than X will not affect the monster. Basically, we will be left with swords only whose strength is greater than or equal to X. And our game score is equal to difficulty X multiplied by number of levels completed. Okay. Now we need to choose the game difficulty in such a way that we have to maximize the game score. So, coming to the explanation, we have an array of swords and V of monsters. Hmm, Initially, or let's suppose I sort the array, and here the elements in the array are in sorted order. Now, suppose if I have chosen a sword with difficulty X, or let me choose a difficulty level X, then basically all the swords behind this will be useless and all the swords after this will be can be used by me. So here let's analyze a case where I choose a difficulty X that is between two elements of an array. Like basically I am choosing a difficulty X that is strictly between two elements. So if I choose this difficulty, uh, uh, then with my leftover swords, let them be some Y swords or something, using my list of valid swords, I can complete uh, some 5 or 6 levels, let them be 6 levels, then my answer will be 6 into X. But here we can see that instead of choosing a difficulty value between two swords, it will be better if I choose a difficulty value that is equal to the sword that is right to the level that we chose just now. Because irrespective of what the difficulty level we choose, we cannot access this sword and we can access swords from here itself. So our best choice will be to choose the difficulty level A4 itself. If we are planning to choose a difficulty level that is between A3 and A4. So, because our value will be multiplied with number of levels completed, and we want this value to be max possible, so that our result will also be max possible. From here, we can conclude that difficulty difficulty level must be equal to one of the sword strength. So, my next step will be to iterate all possible difficulty levels. That will be only n levels because we have n SWOT strengths only. Our array is our array contains all the strengths and it is of size n. So we have only n possible difficulty levels. Now for each difficulty level, uh, so let's suppose after we fix the difficulty level, my first step will be to fix a difficulty level. Then we will be getting the number of SWOTs. Like for example, if the SWOTs are 1, 3, 5, 7, 11, 13, if I fix a difficulty level equal to 5, then my number of SWOTs are 4. So in this way, if we fix a difficulty level, we will get the number of SWOTs. After getting the number of SWOTs, what we have is we have array B containing the monster number of strikes a monster needs in a level, right? So let the array elements be B1, B2, B3, B4, B5, so on. If if I am able to complete till a level, I'll take an example of 3. For example, 3 here. Then total number of strikes I will need is B1 plus B2 plus B3. That is the prefix sum till that level. So if I am able to complete a level I, the total number of swords I need is prefix sum till that level. V1 plus V2, so on till Vi. Okay. So now we have number of swords and we have to find the maximum I such that prefix sum of Bi is less than or equal to the number of swords we have. And we can see that. So to find this, initially let's start by making a prefix sum array of B. Prefix sum array of B. After making the prefix sum array, our problem prefix of I equal to summation of Bi from I equal to 1 to I from j equal to 1 to I summation of Bj. Now after making the prefix sum array, our goal is to find an index I such that prefix of I find max size such that prefix of I is less than or equal to my number of slots. Let them be some element y. This can be easily found using the upper bound of an array. What I'll do is I'll initially take the upper bound of prefix sum array, upper bound from prefix sum array of element y. What upper bound will return is it will return the min index that is strictly greater than y. Okay. So after taking the upper bound in prefix sum array, I'll get the minimum index that is strictly greater than I. So all the indices before that are less than or equal to I, which means that all the indices before that are less than or equal to y, because this is the minimum possible index that is strictly greater than or equal to I. So my answer will be, uh, if this is the upper bound index, my answer will be number of elements between this current index, between the index written by the upper bound. If we take the index as zero index, for example, here 0, 1, 2, 3, 4, 5. If it is zero index, my answer will be basically index itself. Because as this is strictly greater, I have 5 elements before this current one, which are less than or equal to y. So my answer will be 5 itself. And that's all. Our problem reduces to taking the upper bound of the prefix sum array and returning the index of that upper bound. Coming to the code, initially I am sorting the array and I am taking the prefix sum of array B. I am modifying the array B itself. There is no need to create another array. So after taking the prefix sum of array B, here Yeah, initially I am uh, doing answer equal to 0. And in this for loop, I am iterating over all possible, what we call that, uh, all possible difficulty level. So let x be the current difficulty level, and it will be equal to AI. So after that, what I am doing is, uh, if I fix x equal to AI, the number of spots which have the values greater than or equal to AI will be n minus I. After that, I am taking the upper bound, and basically upper bound returns a iterator, and if we subtract it with the starting pointer or beginning of the vector, we will get the index of the upper bound. Here I got the index of the upper bound, and then after getting the index of the upper bound, basically these are the number of levels I can complete. So my answer will be, uh, answer for the current difficulty level will be x into x is the difficulty level and number of levels I am able to complete. And my answer will be maximum of all possible answers at all possible difficulty levels. And finally, I am printing the answer. Okay, now moving on to the next question. We have an array of length n, and we have to answer n questions. In the ith question, we are required to determine the minimum number of elements from the array that need to be selected from the board. And here we have to note this point that we are allowed to use the same element multiple times. And our goal is to find the minimum number of elements to be selected from the array such that their product is exactly equal to I. All we have to report that it is impossible to achieve such a product. So coming to the constraints, n is bounded by 3, 5, and all the elements are between 1 to n. For ith question, we need to output the minimum elements that we need to select from the array such that our product is exactly equal to I, or minus 1 if it is if it is not possible. So here I'll go through one of the test cases. These are the array elements. So in the first test case, 1 cannot be obtained, so it will be minus 1. 2 can be obtained by directly selecting one, simply selecting one element, so answer will be 1. And 4 can be obtained by selecting A2 twice. Basically, by selecting this element 2 times, I can obtain 4. So my answer will be 2. And finally, here A8 can be obtained by selecting this element 3 times. Like in order to obtain 8, I'll select this element only 3 times. 2 into 2 into 2, that's equal to 8. So coming to the explanation, in these type of questions, our first observation is to see, uh, like let's imagine I can, uh, or let us set a goal. Goal is to find min number of elements such that product of elements we selected equal to I. Okay. So here, first, I thought something like this. If I need to make an element I'll imagine or I'll assume that I can make I know the answers for all the elements that are less than I. So if I know that, can I make I or not? So in order to make I, what we can observe is that hmm, let all the previous values, if we know all the previous values and we know, need to know the current value. So this will be generally generally done by DP. So in order to find DP of I, I'll first look at all the divisors of I. So number of divisors, number of divisors of n will be at an order n power 1 by 3. So it's okay if I iterate over all the divisors. So basically, I equal to some divisor of I into y, and this y is something smaller than or equal, less than or equal to I. So I can do something like this. For dp of I, what I can do is, if there is a divisor such that it belongs to array, uh, not dp of I. Here, if I can represent I in such a way that there is a divisor that is in array and into some element y. And if we are multiplying with a divisor, here we'll only take the perfect divisors, that is, I am not including d equal to 1. So here d not equal to 1. If d is not equal to 1, this y is strictly less than n. So y will be less than n. So basically, if I can represent I in this format, what I can tell is dp of I equal to, as y is strictly less than n, dp of y, number of ways to make y, number of ways to like min number of elements needed to make y plus 1, because here we are including an here we are taking another element d that is in a, because we are doing d into y, and dp of y will be minimum of all possible dp of, here we can represent y as y equal to I by d, all possible I comma d where d is in array A. So here initially what we can do is, we can initialize the dp array by 1 of all elements if they are present in the array. Or there is no need to do that. We can do it on the run also. What uh, what we'll do is, from I equal to 1 to n, if I is in array, I'll do dp of I equal to 1. And this will be the minimum possible size, so I can safely continue from here. Else, if I is not equal to array, I will iterate over all divisors of I and set the dp of I equal to minimum possible value of dp of I by d plus 1, where uh, also here we have to note the d is in array. All the divisors of I which are in A. and I'll set the dp of I to the minimum of dp of I by d plus 1. And that's all. We can initialize the dp array with some very big value like 118 or something. Uh, and after every step, we are either setting it to 1 and we are setting it to minimum of dp of I by d plus 1. And finally, our final answer will be the values in this dp array. Values in dp array. I'll explain this question with the code. So here also we have another issue in this. We have to find divisors of I quickly. Okay. Basic. So this can be pre-computed. Like divisors of all elements from 1 to n, or not exactly n, from 1 to maximum possible n, I will pre-compute it. Here the value is 3, 5, right? From 1 to 3, 5, 3, 5. I will pre-compute all the divisors. Uh, so that for all test cases, if I need a divisor for current element, I can, it will simply cost me O of n power 1 by 3 time after initial pre-computation. This pre-computation can be done using CU. I'll show the code here. It's a pretty standard method. So what I'm doing is I have created a vector of divisors, and for each I equal to 2 to n, mm, the I will be a divisor of all multiples of I, right? So I'll iterate over all the multiples of I that is less than n. J equal to 2i, j less than n, and I'll increment j by I. I am pushing into a divisors vector of j, the element I. In this way, I'll pre-compute all the divisors for n equal to 3, 5 for all possible n values. After that, our task is very simple. Here, initially, I have created a visited array. Visited array is just to check if current element is present in array or not. After that, I am initializing this DP array with a very large value. Here INF is simply 1E18, or this value can be 1E9 or something also, or 1000 will also suffice because any element can be produced in at most log n. So if we keep some small number like 1100 also, it will be fine in this initialization. After that, I am setting if the element is present in A, I'll setting the DP value of 1. Else the value will be this big number itself. After that, for every I equal to 2 to n, I will go through all the divisors and I'll check. If the divisor is present in array A, I will do this. dp of I equal to minimum of dp of I, comma, I plus I by y. Here y is the divisor of I and I by y is strictly less than I. So this value has been already calculated as we are iterating from smaller to bigger numbers. Here we can note that I am not taking I equal to 1 because 1 has no divisors, and in case if my answer is 1 for like my DP is 1 at index 1, that means that the current element is present X. The only way to make I equal to 1 uh, if we have an element in array A which is equal to 1. So that will be already handled here. So from 2 to n I am doing this, and after that, if dp of I equal to INF, I'll print -1, else I'll print dp of I. And that's all. Coming to the F question. So here we have a pizza delivery person GR. And the manager has provided him with 10 coordinates of houses, xi, comma yi, where he needs to deliver the pizza. He will deliver the pizza in following way. The pizza is prepared at point ax, comma ay, and yf, and he starts the delivery from this point. To deliver the pizza, he can move from point xy to 3 points: x plus 1y, x comma y plus 1, and x comma y minus 1. Here we can note that he can move either to the right, I'll show here. He can move either to the right, this is x plus 1 comma y. He can move to the top, x comma y plus 1, or he can go down, x comma y minus 1. But he can't move backwards. So basically, moving back is not possible. He can either move to right or up or down. So after he has delivered all the pizza, he returns to home at point bx, comma by. And what we want is, we want the delivery to be as fast as possible. So we need to find the minimum delivery time for all the pizzas. And it's guaranteed that the delivery is always possible. Here we are given the initial coordinates, the final coordinates, and also the coordinates of all the delivery points. Here we have to note a point that uh, AX is strictly less than all the delivery points, and all the delivery points are strictly less than BX. So, what we can first interpret from this delivery pattern is that as he can move in this way only, first he has to complete an X coordinate, complete delivery at X. Like basically, at X, he can, at a certain X, he can he can freely move to all Y coordinates. Okay, as he can go up and down, he can move freely move to all Y coordinates. But as soon as he goes from x to x plus 1, he cannot go back. He cannot go back to x again. So basically, before making this move, like before making a right side move, he has to complete all deliveries at x. Complete all deliveries at x. Then only he can move to x plus 1. He can move to x plus 1. So from here, let's assume that this is the start point, and these are the points at a current certain delivery. What I'll do is, so initially from start point, I'll move to right and reach the x coordinate where all deliveries are there. From here, what he can do is, he can either first go to lowest y and then go to the top, or he can do something like this. Here, he can either go to the top and then go to the lowest y. Okay. So for every x coordinate, he has like finally he can end up at two positions. Like this is the start coordinate list. I'll only draw the maximum and minimum y's at a certain x, and let this be an x coordinate. Let this be another x with maximum and minimum y's. So after delivering, he can either be here or be here after completing all the deliveries. So for every new x, Like let this be x0, x1, x2. What I'll see is like let's suppose if my delivery guy is at this point, how much time will it take for, if my delivery guy is here and finally he ends at this point. Like let this be point 1, point 2, point 3, point 4. If I have the value, uh, if I have the min time he takes to reach 1, what I'll see is from 1 to 3 and 1 to 4. How he will go from 1 to 3? He'll basically go till here, then he'll go to 4, then he'll go to 3. I'll calculate the time he'll take if he goes from 1 to 3 and 1 to 4. Also, I'll calculate the time he will take if he goes from 2 to 3 and 2 to 4. 2 to 4. How he can go from 2 to 4 or 2 to 3. First, he will go to this x coordinate. Then from here, like if he wants to go to 2 to 4, here we have to note that in order to go to end up at 4, he has to initially complete all the deliveries at x2. So first he will go to 3 and then he will come back to 4. Okay. If he wants to go from 2 to 3, then he can simply go in this way. Like he will go from 2 to 3 and complete all the deliveries in between. So after calculating these values, what I'll do is the minimum possible time he needs so that he takes so that he has to finally end at 3 will be minimum of 1 to 3 and 2 to 3. Like how much time he takes from 1 to 3 and from point 2 to point 3. And minimum possible to time he needs to end at point 4 will be minimum of 1 to 4 and 2 to 4. 1 to 4 and 2 to 4. So that's all. Like basically we can keep on repeating the process after getting the minimum time he needs to end up at these 2 points. What I'll do is I'll simply repeat the same process at another x coordinate. And similarly, I will calculate the minimum time he needs to reach here and minimum time he needs to reach here. And here we end up with two cases, or I'll keep on explaining with the code. So I'll explain the cases when we encounter that in the code. Here initially we are given starting point and ending point and the coordinates of all the deliveries. I am taking input all the coordinates of the deliveries and after that I am sorting them. So that all the x coordinates, they are ordered by their x coordinates first, then they are ordered by their y coordinates. Then initially, let this be the topmost point, like what is y1 and what is y2. It has certain coordinate x. Here y1 I am taking minimum, right? Yeah. So the lowest value here is y1, it is certain x, and the highest value is y2. And also here v1 and v2 are initial values. Like v1, v2 is uh, value of time taken. to end up at y1. And similarly, v2 is the time taken to end up at, sorry, here v2 is the value of time taken to end up at y2. Here v1 is the value of time taken to end up at y1. So initially, as we are at starting point, both y1 and y2 are equal to my initial y coordinate itself, ay. And the value of time taken to reach the starting point is obviously 0. And here px is the current x value. Px in the sense, while writing the code, I took it as previous x value. Or we can interpret it as follows. We are having y2 and y1 of a x value, right? In the code, I have named the x value as px. So basically, the topmost point at a location will be px comma y2, and the bottom point will be px comma y1. After that, in j equal to 0, what I am doing in this while loop is that currently I am taking the x coordinate of the current element, while as all the elements in this vector of pairs are sorted by their x coordinates, while the x coordinate is equal to my current x coordinate, which I have initially noted, I will calculate the minimum possible y and maximum possible y. Cx is the current y and current minimum possible y value and current maximum possible y value. Okay. So here in this step, what I am getting is that for a current value of x, what is the minimum possible y value is cy1 and maximum possible is cy2. Okay, for a current x value. So here, number of steps. I will explain this variable extra. Here we are at px, right? Px is our previous x value. So in order to commit current x, we need to we have no other option other than to take these many steps. Current minus px number of steps. So that many right moves will take. So number of moves will be number of right moves will be current minus px. After that, I am computing the values CV1 and CV2. Basically, CV1 is the minimum possible value at minimum possible uh, delivery time so that I end up at CY1. And CV2 is the minimum possible delivery time so that I end up at CY2. So for calculating that, what I am doing is I have created a lambda function here. Here, this function takes two input parameters. Like for example, what this function does is that it takes the input y1. Y1 is basically, I'll show in the diagram. Here it is px, y1, and y2. This is the current x. This is cy1 and cy2. Okay. So what this function does is check y1, comma, what I did, check y1, comma, extra plus v1. Check y1, comma, extra plus v1. The main goal of this function is that I am starting at point y1 and already I have used these many. v1 is the time I need to be at y1 and extra is the time I need to reach at current. So already I have used this much amount of time and I am at y1. So what check function does is that it updates the values of CV1 and CV2, like the current values CV2 and CV1. Here, these are the times, minimum possible time required to be end up at this point, right? So every time when I call this function, what it does it takes that I start at this point and I already used this much amount of time. So with that two information, I'll update the values CV1 and CV2. How I am updating the values in the function, we'll check that. So if the previous y coordinate, this is the y coordinate, right? If the previous y coordinate lies between cy1 and cy2, cy1 and cy2, and this is the x. If previous y coordinate lies between them, in order to update cv1, in order to end up at y1, what I have to do is I have to go to cy2 and then reach at cy1, right? So time taken will be cy2 minus x plus cy2 minus cy1. This will be the time taken to end up here. So that's what I did. CV1 equal to initially I have initialized them with the max possible value, and I'm taking the minimum of previous is the time previously used time, and cy2 minus x. This is cy2 minus x, and then cy2 minus cy1. First I'll reach cy2, and then time taken to travel from cy2 to cy1. Similarly, CV2 will be what will happen on CV2. For CV2, initially I have to go to CV1. I want to end at CY2, right? I'll go to C here and then I'll reach at the top point. So time taken will be x minus CY1 plus CY2 minus CY1. So that's what I have written here. And in the case where is x is less than the lowest value. So this is the case where x lies between both the values, right? In the case where x is less than the lowest value, and let x be somewhere here, then in order to end up, this is cy1. In order to end at cy1, what I have to do is initially I'll go up, then I'll come down. The time taken will be cy2 minus x to go up, and then cy2 minus cy1. So to end up at cy1, the time taken will be this. And if we want to end up at cy2 itself, then here, in this case, I want to end here. So simply I can go like this. Because if I go up, I will obviously cover all the deliveries on the way. So my time taken to end up at cy2 will be cy2 minus x. And that's what I have written here. Similarly, I have also handled the case where here x is less than cy1. Uh, and here x is between cy1 and cy2. When x is greater than cy2, that is the case, here x is below, right? In this case, the x will be above both of them. So in that case, if I want to end at cy1, my answer will be x minus cy1. And if I want to end up at cy2, what I'll do is I'll go from here to here, then I'll come back to here. That will be this value. I'll initially go here and I'll come back. If I want to end up here, then I'll simply travel to the destination, cy1 itself. So in this way, I have used the check function. In check function, I'll check at both the values. Time taken if I start at lowest previous and y coordinate and highest possible previous y coordinate. And here I am passing on the time that has been used. When I'm starting from y2, the time I have used is time taken to travel from previous x coordinate to current x coordinate plus time taken to end up at that y coordinate. This will be my previously used duration. And when I am using y1, this will be my previous duration. After calculating them, what I did is I'll update the y values. Like we have calculated cy1 and cy2 and all the values we have calculated them, right? So I'm updating the values so that in the next iteration, the previous x value will be the current x value, like the x value of the previous iteration. And finally, what I'm doing is I'm printing out the minimum possible time of v1 and v2. Here we have to note that I have already pushed the final coordinate in the vector v itself. So my final answer will be minimum of v1 comma v2 itself. And that's all.